Very good morning, dear students and friends. Now we are going to see the video lecture on the thin cylindrical shell, that is the design of the diameter of thin cylinders, which is subject to internal fluid pressure of 5 Newton per square millimeter and of thickness 5 mm, and the allowable stress in the material of the cylinders, that is F is equal to 50 Newton per square millimeter. And what about the corresponding the diameter of the thin cylindrical shell, which is safe under the hoop stress and longitudinal stress? And what will be the major and minor principal stress? And also, what is the maximum shear stress developed? So these are the unknown factors we are going to find in this design. You know that the thickness of the thin cylindrical shell should be greater than or equal to PD by 2F. So here the thickness should be greater than or equal to PD by 2F. We are substituting the numerical values from the given problem. So therefore T is equal to, pressure is 5 into the diameter of thin cylinder, that is unknown, divided by 2 into 50. So if you are finding the diameter is unknown, we are simplifying it, you will get the diameter of 100 mm. So if the diameter is 100 mm and the thickness is 5 mm and the allowable stress in the material is 50 Newton per square millimeter, now what will happen to the hoop stress? The hoop stress F1 is equal to PD by 2T. That is, pressure is 5 into diameter is 50 divided by 2 into 5. So you are getting the F1 is equal to 50 Newton per square millimeter. Then what about the longitudinal stress? So the longitudinal stress F2 is equal to PD by 40. That is half of the hoop stress, that is half of F1. So that is equal to 50 by 2. So if you are simplifying it, F2 is equal to 25 Newton per square millimeter. And we are going to find the maximum shear stress, tau max, that is equal to the maximum shear stress rotation Q max is equal to the average of the major and minor principal stress. So therefore, sigma 1 is equal to here F1, that is equal to 50 Newton per square millimeter, and sigma 2 is equal to minor principal stress, that is equal to F2, that is 25 Newton per square millimeter. So therefore, the Q max is maximum shear stress, that is equal to sigma 1 minus sigma 2 by 2. So if you are substituting the values, therefore tau max or Q max is equal to 50 minus 25 divided by 2. So we are simplifying it, we are getting 25 by 2, that is equal to 12.5 Newton per square millimeter. So the maximum shear stress is 12.5 Newton per square millimeter or megapascal. So from this we know that once the thickness, fluid pressure, material is given, you can be able to find the diameter of the cylindrical shell. Or otherwise, if the diameter is given and the other values given as known, that of the pressure, the diameter, the thickness can be derived. So this is about the design of thin cylindrical or thin cylinder from the strength of material course. Thank you very much for patient listening. வாழ்க வையகம், வாழ்க வளமுடன்.